The universe contains 2 trillion galaxies. Imagine each galaxy as a grain of sand, and you would need 10 Sahara deserts to hold them all. Yet for all their unimaginable vastness, these cosmic cities are surprisingly fragile, constantly facing a cosmic death sentence, running out of the very fuel that sustains them. What really happens when a galaxy exhausts its lifeblood, the gas needed for new stars? Galaxies are vast cosmic islands, each a stellar nursery where new stars are born from colossal clouds of gas and dust. This interstellar medium, primarily hydrogen and helium, comprises about 10–15% of a galaxy's mass and is crucial for stellar ignition. Without this raw material, the ceaseless cycle of star birth grinds to an inevitable halt. When a galaxy's gas reservoir dwindles, star formation rates plummet, marking the onset of its red and dead phase. This transformation often begins with the consumption or expulsion of cold gas from the disk, leaving behind older, redder stars. You are witnessing the slow, majestic death of a cosmic city, gradually fading into obscurity. One primary cause of gas depletion is galactic mergers, where the gravitational forces strip away or heat up the gas. For example, the Antennae Galaxies are currently undergoing a spectacular collision, driving massive starbursts that consume much of their gas in intense flares. This chaotic dance can quickly exhaust a galaxy's star-forming fuel. Supermassive black holes residing at galactic centers can also dramatically influence a galaxy's gas supply. These active galactic nuclei, or AGNs, launch powerful outflows of energy that heat and expel gas from the host galaxy. This feedback mechanism, observed in galaxies like M87, can effectively quench star formation across vast regions. Another significant process is ram pressure stripping, particularly for galaxies moving through dense galaxy clusters. As a galaxy speeds through the hot intergalactic medium, this pressure acts like a cosmic headwind, stripping away its cold gas. The Virgo cluster contains numerous galaxies visibly affected by this violent process, leaving behind long trails of gas. Within galaxies themselves, massive stars and supernovae also contribute to gas depletion through powerful stellar winds and explosions. These events inject tremendous energy into the interstellar medium, heating and dispersing gas clouds. While they enrich the gas with heavier elements, they also push it out of star-forming regions. As a galaxy loses its gas, its appearance dramatically changes, evolving from a vibrant spiral to a quiescent elliptical. Spiral galaxies, rich in gas and young blue stars, become more like the red and dead ellipticals, dominated by older, redder stellar populations. This morphological transformation is a key indicator of gas exhaustion. Dwarf galaxies are particularly vulnerable to gas depletion due to their shallower gravitational wells. The Large Magellanic Cloud, a satellite of the Milky Way, shows signs of past interactions that stripped some of its gas. These smaller systems can lose their gas completely, halting star formation permanently and becoming faint stellar relics. The Andromeda Galaxy, our closest large galactic neighbor, will one day merge with the Milky Way, triggering a colossal starburst event. This intense period of star formation, fueled by the available gas, will rapidly consume much of the combined gas reservoirs. The resulting Milkomeda will then likely settle into a gas-poor elliptical form. One fascinating consequence is the creation of jellyfish galaxies, like JO206, which stream long tails of stripped gas as they move through clusters. These ethereal structures glow with newly formed stars ignited by the stripping process itself. They are transient masterpieces, showcasing the violence of gas removal in real time. Surprisingly, a galaxy can appear dead in optical light, yet still harbor vast amounts of hidden, cold gas that has been pushed to its outer regions. Observations with radio telescopes like ALMA reveal these cold gas reservoirs far beyond the visible stellar disk in some galaxies. This unseen fuel might offer a chance for future star formation. However, this hidden gas is often too diffuse or too far from the galaxy's center to easily collapse and form new stars. It exists in a tenuous state, slowly dissipating into the intergalactic medium over billions of years. So even if the gas is present, it might not be accessible for rejuvenating star birth. The circumgalactic medium, a halo of hot, diffuse gas surrounding galaxies, plays a critical role in this story. This gas, heated to millions of degrees, can replenish a galaxy's supply by cooling and falling inwards. However, if this inflow is insufficient or inhibited, the galaxy will inevitably run out of cool gas. Star formation efficiency also drops dramatically when gas is depleted, leading to the formation of fewer and less massive stars. Instead of giant, blue, short-lived stars, you get smaller, redder, longer-lived stars. This shift is evident in the stellar populations of quenched galaxies. For some galaxies, the gas isn't fully expelled, but instead becomes too hot to form stars. The hot gas in the halos of massive elliptical galaxies, often observed by X-ray telescopes like Chandra, prevents cold gas from settling in the disk. This effectively sterilizes the galaxy, rendering its remaining gas inert. The most surprising fact about dying galaxies is that they sometimes experience brief periods of rejuvenation. If a gas-poor galaxy interacts with a gas-rich companion or captures a smaller dwarf galaxy, it can trigger a new, albeit short-lived, burst of star formation. This offers a temporary reprieve from its demise. These fleeting starbursts can be incredibly intense, burning through the newly acquired gas extremely quickly. The Ring Nebula is an example of what might happen when a galaxy gets a sudden influx of gas, creating a spectacular but short-lived burst of new star formation. It's like a final, desperate gasp of life. Ultimately, a galaxy that runs out of gas becomes a passive galaxy, simply aging gracefully as its existing stars slowly die out. There are no new stars to replace them, so the galaxy grows progressively dimmer and redder. The ultra-red galaxies observed in distant surveys are often excellent examples of this state. The cosmic web, the vast filamentary structure of matter in the universe, dictates the flow of gas into galaxies. Galaxies located in dense knots of this web often have access to a continuous gas supply, while those in sparse regions are more prone to depletion. The large-scale environment profoundly influences a galaxy's fate. Observations of distant galaxies, seen as they were billions of years ago, show a higher proportion of actively star-forming, gas-rich spirals. This indicates that gas depletion is an ongoing process throughout cosmic history, progressively transforming the universe into a more red and dead landscape. Future galaxies will largely be elliptical, formed from the mergers of today's spirals that have exhausted their gas. The universe is evolving towards a state where star formation becomes increasingly rare, a long, slow fading of cosmic light. The fate of our own Milky Way is heading towards this path. Even the most isolated galaxies, free from cluster environments or major mergers, will eventually run out of gas from internal processes. Stellar winds, supernovae, and the gradual conversion of gas into stars will slowly deplete their reservoirs. This is an unavoidable consequence of stellar evolution. The rate at which galaxies run out of gas varies wildly, depending on their mass, environment, and merger history. Massive galaxies in dense clusters, like those in the Coma cluster, tend to run out of gas faster than isolated dwarf galaxies. It's a complex interplay of cosmic forces. However, it's not just a loss of gas, it's also a loss of potential. Without fresh gas, there are no new planetary systems, no new chances for life to arise in those galaxies. Each gas-depleted galaxy is a cosmic graveyard of what might have been. Studying gas depletion helps astronomers understand the fundamental processes driving galaxy evolution and the life cycle of stars. Projects like the GASS survey, GALEX Arecibo SDSS survey, specifically target the neutral hydrogen content of thousands of galaxies to map these changes. The ultimate fate of the universe is closely tied to these gas dynamics. If all galaxies eventually run out of gas and cease forming stars, the cosmos will become an increasingly dark and quiet place. The epoch of star formation will give way to an age of stellar remnants. Thus, what really happens when a galaxy runs out of gas is not just a singular event, but a complex, multifaceted transformation. A slow, cosmic death that redefines the very structure and potential of a galaxy, leading to a universe that is ever-changing. If you found this cosmic journey through dying galaxies as fascinating as we did, make sure to like this video and subscribe for more awe-inspiring space content. What do you think is the most dramatic way a galaxy could run out of its star-forming gas? Let us know in the comments below.